Okay, this video is brought to you by Brilliant.work, and if you guys want to learn how to solve interesting and challenging math questions, be sure you guys go check them out. For example, how would you solve this big integral, right? This is not easy at first. It's not easy for me neither, okay? I had to really, just kind of enhance on my integration skills in order to see what are the other approach I can solve such integral. I will have a link to their integration tricks page for you guys in the description. Be sure you guys go check it out. But as always, please go try this first. Okay, now let's go over how to solve this integral. But I don't think we can find an antiderivative for this, right? However, we do have this integral going from 0 to infinity, so at the end of the work, we should be able to just get a number for the answer. So that's good. And first of all, I see that we have a quotient instead of the ln. So we can use the ln property to break this down, right? So let me just rewrite this. This is the integral going from 0 to infinity. On the top, we will have ln of 1 plus x to the 11th power. And then minus, because that was a quotient, another ln, and this time is with 1 plus x to the third power inside, all over this right here is still 1 plus x squared times ln x dx. Okay, now, by looking at this, I don't know if I can do any kind of substitution and simplify this a little bit. And this is the time that we may have to use some different properties of integrations that we may not have seen in the textbooks and things like that. And be sure you guys go check out the Brilliant page. I will have the link to that page with a list of integration tricks that I think you guys will like. And just go check it out. And in fact, this is one of the properties that I'm going to use. Okay, and I actually do a video recently on that, so you guys might notice that that was a prep work for this one. Okay, the property that I'm going to use is that I'll just put on a note. When we have the integral going from 0 to infinity, original f of x right here, and I'll just say this is my f of x. This right here, it's actually the same as the integral going from 0 to infinity, f of 1 over x, and then over x squared dx. First of all, if you want to see how this is true, I will have the link to that video in the description for you guys. So be sure you guys check that out. And also, the reason I want to try to use this is because, okay, of course we have the 0 to infinity. And when I plug in 1 over x inside of this x right here, instead of the ln, actually you will see some repetition and hopefully these things will come out. And this is going to be similar to the original one, and we can do some combinations and cancel out the things that we don't want. Hopefully that's the case. So with that being said, let's see how does this look like. So this right here is the original. I will first plug in 1 over x into all the x first, okay? So this right here is the integral going from 0 to infinity, and then we have ln of 1 plus, originally it was x to the 11th power, but this time I plug in 1 over x in here, so we actually have 1 over x to the 11th power, isn't it? And then minus ln of 1 plus, plugging this into here, 1 over x to the third power, isn't it? And then over 1 plus, I'm just plugging 1 over x into here for now, so 1 over x squared, and then lastly multiplied by ln of 1 over x in here. And of course, don't forget the dx, otherwise people will sue me. Anyway, this right here is just the expression for f of 1 over x. And I still have to divide this by x squared. So that means I will have to put down an x squared in the denominator here. And now let's do some algebra. Let's focus on the inside here. So for example, this right here, 1 plus 1 over x to the 11th power. Of course, I can write the 1 as x to 11 over x to 11 plus 1 over x to 11. And that's a lot of 1s right here, right? Anyway, this is just x to 11th plus 1 over x to 11. And when you put this inside of the ln, then you can do the ln property again. You can break them apart into subtraction. So I will do that. So this is actually the same as the integral going from 0 to infinity. Okay. This right here is ln of the top, which is ln of x to 11 plus 1. And then minus, right, because we have the division inside, so it's a minus ln of x to the 11. And then similarly, we do the same thing, and you guys see the deal. This is going to be minus, and the first one is going to be, and because this is a minus, let me just put on bracket first. Anyway, the first one inside is ln of x to the third power plus 1, and then minus ln of x to the third power, like this. And then I have to squeeze in my dx. So of course, it's just on the side. This is not in the denominator, okay? Disclaimer. Anyway, this right here, I can just distribute it if you just focus on that part, right? Okay, so we get x squared plus 1, right? Because this times that, the x squared cancel. And this right here, I can just change that to multiplying by negative, let me just put on the negative ln of x. Okay, so it's like this. Okay, so that's pretty much that. And of course, if you would like, can distribute this, so this actually becomes positive. Notice this one in blue versus the one that we have originally. The denominator are similar in terms of the function part, and then on the top we have this and that are being similar, right? Okay, so let me just kind of combine them together to see if there's anything that we can do. And especially this is actually going to be a negative version of all that because we have the negative multiple right here, right? So this is my write out, okay? So let's see, I'm going to call this to be I, okay? So that way we can just name this integral to be I. I don't have to write it down like a few times. And I will also call this to be I, of course, because this and that are the same because of this property. And now moving forward, or maybe moving downward. Let's see. Let's put down the I in black, right? I in black plus the I in blue. So let me just write this down for you guys. And now, let's see what we have. And of course, I plus I is just going to be 2I, so keep that in mind. And I'm going to write this down for the I in black. I have the integral going from 0 to infinity, ln of 1 plus x to 11th power minus ln of 1 plus x to the third power over this for the denominator, which is 1 plus x squared times ln x, okay? And because these two integrals, they have the same limit of integrations, so I'm going to put the blue integral inside here as well. And thanks to this negative here, right, because this is a negative times ln x, so when I add them, I'm adding a negative version, this becomes a minus, okay? So this is right here now. And the denominator, it's actually the same. X squared plus 1 is the same as that, so it doesn't really matter. So I will just write it down, this right here, to be 1 plus x squared. And then this right here is ln of x. On the top, this right here is ln of x 11 plus 1. And it's actually the same as that. I should have written it backwards, but it doesn't really matter. And let me put this down first. This is minus ln x to a third power plus 1. And then this is minus, and check this out. This time, we have only ln of x to the 11th power. So what can we do? Of course, I can bring the power to the front. This is just a log property. We are not doing the power rule of the differentiation, okay? So let me put down 11 in the front and then ln of x. And check this out. Negative times negative, that's positive now. And then right here, this is x to the third power inside. I can bring the power to the front. So we have 3 ln of x like that. And in the end, of course, I'll close this with a dx. Okay? Cool. And now a lot of good things are actually happening. Why? Because you'll see this right here is the integral from 0 to infinity. And check this out. We have the first integral right here. subtract it with the second integral here, right? And this and that are the same, and we have the same denominator, so I can just say cancel this out to be 0. And likewise, this is a negative ln of 1 plus x to the third power minus minus, so it becomes plus, negative plus, and the input are actually the same, right? So we can cross these two out as well. And let's see, on the top, what do we actually have? Well, it's actually just this part, isn't it? Because we have negative 11 ln x plus 3 ln x. So this right here will give us negative 8 ln x. But I'm minusing that, so it's a positive 8, isn't it? So I'll put down the positive 8 ln x on the top over the denominator, which is 1 plus x squared times ln x. Ooh, look at what happened. As we can see, the ugly ln x cancel each other out, because this time now we can totally integrate this, right? So this right here is just the integral from 0 to infinity. Let me put the 8 in the front, and now we have just 1 over 1 plus x squared dx, and of course this is just 8 times the inverse tangent, so I will write it down as this, with a negative 1 for the inverse tangent notation. And we are going this from 0 to infinity, so this is 8 times the inverse tangent of the infinity, and then minus inverse tangent of 0, like this. And in the end, we see that this right here is just 8. This right here, inverse tangent of infinity, is just pi over 2. And this right here is just 0. So if you look at all this right here is just pi over 2 times 8, which is just 4 pi, right? Okay, but 4 pi is not the answer, because this is actually I plus I. So therefore, I'll just write this down. Therefore, we see that 2i is equal to 4 pi. Of course, I'll just put on literally, of course. I, which is the original, is equal to divide both sides by 2. You get 2 pi. So the original integral right here, let me just write it down to be respectful. The integral from 0 to infinity of that big thing, ln of 1 plus x to the 11th power over 1 plus x to the third power over 1 plus x squared times ln x. This is equal to 2 pi, okay? So the strategy here is that try to come up with something that's similar to the original, and then add up these two integrals and hope for the best. This time it was the best because a lot of terms cancel out, and we actually end up with something that we can actually integrate, right? So this right here is it. If you guys like this integral, please give me a like and also leave a comment down below and let me know what you guys think. And be sure to check out brilliant.work and use the link brilliant.work/blackpenredpen. Over there, you guys can find a lot more interesting and challenging math questions that I think you guys will enjoy solving them. I like to go try out their problems of the week questions. They have the problems of the week every week, and they have different levels. You guys go try it, and in fact can do them for free. And keep in mind, it is definitely okay that we don't know how to do some questions the first time, right? And that's what learning is all about. And in fact, I tell my students that one of the best ways to learn math is challenge yourself and attempt hard questions. And when we attempt hard questions, sometimes we fail the first time, maybe the first few times. It's okay because we actually get the most out of the questions that we cannot solve the first time. All right? And at Brilliant, they encourage you to not solve difficult questions, and they have courses designed for you to learn new things. And they have the annual premium subscriptions. I think you guys will like them too. And if you guys use the link brilliant.work/blackpenredpen, you guys can actually get 20% off if you are one of the first 200 people to sign up for the annual premium subscription. But anyway, you guys can always go there and try their problems of the week and let me know what you guys think. And you guys can also share solutions on their community page. And hopefully you guys like this video, and if you guys are new to my channel, please subscribe, and I like to make math videos for you guys. And as always, that's it.